Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is the answers over the week 1 discussion set problems. So you'll want to watch this after you post it in case you got any of the answers wrong and you're not sure why. I'm just going to post this, and this is a great review to help you get ready for the test, and it's basically instructions so you know what the heck's going on if you're lost on a problem. So for number 1, A through D, we were supposed to decide whether the statement is true or false. If it is false, provide a counterexample. So if a number is divisible by 2, then it is even. That statement is true. I can't find any number that, basically the definition of a number being even is that it's divisible by 2. So if a competition is a race, then its competitors are running. What about a swimming race or a car race or many other races that we can have? So this is false, and I gave a couple of counter examples there. You just need one though. If it says if a card is selected from a deck and it is a queen, then the card is a face card. Well, face cards are jacks, queens, and kings. So if it is a queen, if we selected a queen, then it is for sure a face card. So that statement is true. Face cards are jack, queens, and kings. Then the next question, or the next statement, says all four-sided figures are rectangles. Well, this is not necessarily true because we can have like a square, which isn't, actually a square is a rectangle. Let me go back. So we can have like a parallelogram or a rhombus, which are four-sided figures that aren't rectangles. So not all four-sided, or like a diamond, a diamond's not a rectangle, and that's a four-sided figure. Okay. A diamond's a rhombus, but anyway. So then, round the number to the indicated spot. Rounding is going to be a big thing for us for the rest of the semester, so you got to have these skills ready. So round to the nearest tenth. Well, the nearest tenth is the first decimal. Whenever I round to a particular spot, I look to the number to the right. If that number's 5 to 9, then I add 1 and round up. If it's 0 to 4, then I don't. So since the number to the right of 4 is a 5, I'm going to call it 5.5 to the nearest tenth. To the nearest whole number is, the actual 1 spot. And since the number to the right is 4, then we just call it 5. To the nearest thousandth. Okay, so thousandth is the third decimal spot. We call it 10, 100, thousandth. So I look at this 9, and that's the spot that I want to round to. So I'm looking to the spot to the right of that, and it's a 5. Since that's a 5, this is going to round up. But since this is a 9, and I got to add 1 to that, it's going to basically be a 10, and I got to carry 1 over there. So it's going to be 5.460. Oops, 460. This 5 added 1 to the 9, which gave it basically rounded this up to 60. To the nearest hundredth is 10 hundredths, so I look at the third decimal spot, that's a 9, so this is going to be 5.46. And to 4 decimal places, so I look at the fourth, I look to the right. Since this is a 2, I don't round up, and I just call it 5.4595. Okay, next one. It says at the beginning of the year, the odometer in a car read 25,124 miles. At the end of the year, it read 37,364 miles. If the car averaged 24 miles per gallon, how many gallons of gasoline did it use during the year? Well, I want to figure out how many miles it traveled. So if I do the 37,364 minus the 25,124 miles, I'll get 12,240 miles. That's how far it traveled. And it averaged 24 miles per gallon. So if I divide that by 24, then that should give me the number of gallons that it used, which is 510 gallons. Next one, it says a college tutoring center pays math tutors $8.15 per hour. Tutors earn an additional $2.20 per hour for each hour over 40 hours per week. A math tutor worked 42 hours one week and then 45 hours the second week. How much did the tutor earn for the 2-week period? So what I'm going to do, what's going on here? Hold on a second. So what I'm going to do is figure out the regular pay. So I'm going to do 40 hours. Well, really, they did 80 hours of regular work, 2 weeks at 40 hours each, so 80 hours times the $8.15 per hour that the person makes. So 80 times $8.15 is $652. Okay, then the first week they worked 2 hours overtime, and in the second week they worked 5 hours overtime, so they worked a total of 7 hours overtime, and they make $2.20 per hour over the original pay. So $2.20 plus $8.15 is $10.35. So I'm going to take those 7 overtime hours and multiply them by the rate of pay. So times 7. And for the overtime, they got 72.45. They worked 7 hours of overtime, and I added the 220 to 815 to get the pay rate there. Then I add these two numbers to get a total of $724.45. $724.45. I should label that with a little dollar marker up front. That is the final answer. Okay, next group. So this is set theory. This is chapter 2 stuff, 2.1 through 2.3. The first, let's see here, 5 through 12. It says use the symbols, the subset symbol or the not a subset symbol. This slash through it basically says it's not a subset, to determine if set A is a subset of set B. It's going to be a little bit easier for me to just basically verbally describe these. I'm going to just say yes or no. If it's a subset, I'll say yes. If it's not a subset, I'll say no. And you can kind of see how it's already moving my icons over, so that's why I'm kind of writing it this way. It's difficult to get this not a subset symbol in our documents. Okay, so in order for a set to be a subset of another set, everything in the well, if A is going to be a subset of B, then everything in A must be in B. In other words, I won't be able to find anything in A that's not in B. If I find any element in A that's not in B, then I'll say it's not a subset. But if every element in A is also in B, then it's a subset. So A is rain, snow, sleet. B is rain, snow, sleet, and hail. So yes, this is a subset, and I would use the left notation there, the subset notation, but it's hard to get it typed on this computer, so you'll just be able to write that on your test. Now on number 6, they reverse the sets. They say A is rain, snow, sleet, and hail, and B is rain, snow, and sleet. Well, since A has hail and B does not, then A cannot be a subset of set B. Number 7, A is QRST, the letters QRST, and B is just the letters Q and R. Well, S and T are not in set B, so no, this is not a subset. A is not a subset of B. The next one, A is the empty subset, and B is the letters A, B, C, D, E, F. Whenever we have the empty subset, that's always a subset, so the answer is yes. If we reverse the sets here, like in 9, A is A, B, C, D, E, F, and B is the empty set, all the elements in A are not in B, so no, this is not a subset. Okay, next one, 10. It says A is 13579, B is 39576. Well, it looks like this number 1, this element 1, is not in set B, so basically that is good enough to say no, it's not a subset. I found one element in A that's not in B, so it's not a subset. It's pretty close, but not enough. And then 11, it says A is Coca-Cola, Dr. Pepper, Mountain Dew, and B is the set of all brands of soft drink. Well, the Coca-Cola, Dr. Pepper, and Mountain Dew are brands of soft drink, and they are all in the set of all brands of soft drinks, so this is a subset. And number 12, A is just this is another way of writing the empty set, and B is salt, butter, and mayonnaise, which could be, say, ingredients or something. Whenever we have the empty set, it's always a subset, so yes, it's a subset. Okay, then the last 5 problems are set operations. So for each one of these, I'm going to perform the operation and give the answer as a set. So we refer to U as the universal set, meaning basically like U is all elements, possible elements that we're going to deal with, A, B, C, D, E, F, G. A is the subset A, B, C, D. B is the subset C, D, E, F, and C is the subset A, E, G of the universal set. So when we do A union B, that means we want to list everything that's in either A or B. We don't list anything twice. So that's going to be A, B, C, D, E, and F. I know that C and D show up in both, but we just list them once. Remember, the union is really just the list of both sets elements, as long as we don't repeat anything. Or list it twice, I guess what I mean. A intersect B. This is the set of elements that are in A and in B at the same time. So C and D are those elements. C and D are in set A and set B at the same time. B intersects C, so we want to find the elements that are in B and also in C at the same time. That looks like it's going to be the letter E, the element E, excuse me. So the intersection between B and C is just the set E. And then this one says A intersect C complement. Well, I got to do some work to figure out this one first. C complement is the set of everything in the universal set that's not in C. So C complement by itself is going to be B, C, D, and F. Everything but A, E, and G. Okay, so that's B, C, D, and F. That's what C complement is. So now I want to take A and intersect it with that, which means what elements are both in A and in C complement? Well, that's going to be B, C, and D. All right, then the last one. We work with the innermost parentheses first, so we got to get what C union B is first. Once we get C union B, then we'll be able to figure out the complement of that. So C union B is everything in C and B and or B. So let's see here. We have the set A, C, D, E, F, G. Okay, and that's C union B. So C union B complement is everything that's not in this set, C union B, but in the universal set. So I think that's going to be B, A, B, C, D, E, F, G. I think it's just B. Yeah, so it's just the element B. So that's my answers to these problems. Hopefully this helped you if you missed any of them. Good luck, and we'll see you next time.